All right, welcome to Foundations 30. This is lesson 4, probability using combinatorics. So in this lesson, what we're going to do is we are going to be doing probability of single events. But what we need to realize is that we are going to bring in our permutations and combinations and all of those things, okay? But keep in mind the general method of finding probability doesn't change. You need to determine the number of possible or favorable outcomes. Be sure to consider all cases. Determine the number of possible, total possible outcomes, and then find the probability, okay? So the probability formula, where it is the probability of an event, is the number of favorable out of the total number. That doesn't change, okay? It's just that it's going to be a little bit tougher maybe to find the number of favorable and the total number of outcomes in these questions. So let's get started looking at an example. Jamal, Ethan, and Alberto are competing with 7 other boys to be on their school's cross-country team. All the boys have an equal chance of winning the trial race. Determine the probability that Jamal, Ethan, and Alberto will place first, second, and third in any order. Okay, so remember our job is to determine the number of favorable and the total number. Okay, and then once we have those, we can use them to find my total probability. So favorable is going to be having Jamal, Ethan, and Alberto win first place, first, second, and third in any order. So if we think of the fundamental counting principle, here's my first, second, third place people. I have 3 choices for first place. That can be Jamal, Ethan, or Alberto. In second place, there would be 2 choices because one of them has already won first, and that would leave one person for third place. So out of those 3, there are 6 possible ways that the 3 of them can win first, second, or third. Now, thinking about the total number of possible outcomes. So again, first, second, and third, it's not actually just the 3 of them running, right? There's the 3 of them with 7 other boys, which means there's 10 boys in total running the race. So I actually have 10 possible outcomes, people that can go first, 9 that could go second, and 8 that could get third. So that becomes 720. Okay, so the probability of my event happening which is Alberto, Jamal, and Ethan winning, is 6 out of 720, which reduces to 1 out of 120. Okay, let's look at our second example. You have 12 tiles that spell out the word Saskatchewan. You place the tiles upside down and mix them up and rearrange them in a row. Determine the probability that when you flip the tiles back over, they spell the word Saskatchewan again. So I'm arranging them in a row and I'm just flipping. Okay, so again, remember that we need to find the number of favorable and the total number. Okay, well, the number of favorable outcomes is just 1, right? It's the off chance that I'm going to flip them all over again and they're going to spell Saskatchewan. The total possible outcomes, so this is a permutation with repeats question, arranging the letters in the word Saskatchewan. So there are 12 possible letters there that I can arrange, but then I need to divide out the repeats. So I've got the S's that are the same, so that's going to be 2 factorial. I've got A's that are the same. There's 3 of those, so that'll be 3 factorial. And I believe that is all of the letters that repeat. So it'll be 12 factorial divided by 2 factorial times 3 factorial, which comes out to be 39,916,800. So the probability that it's going to spell the word Saskatchewan, remember you can just say the probability of the event, but I'm going to get a little bit more specific here, is 1 in 39,916,800. Okay. All right. There are 18 bikes in a spinning class. They are arranged in 3 rows with 6 bikes in each row. 6 friends take the spin class. 4 of them are women and 2 of them are men, and they want to be in the same row but cannot request which bike they will use. Determine the probability that the 6 friends would be in the same row with 2 men at either end. Gosh, this is really a loaded up question. Okay, so we want the probability that the 6 friends would be in the same row with the 2 men at either end. Okay, so it doesn't change. We need to find the number of favorable outcomes and then the total number. Okay, so the number of favorable outcomes. So thinking about what we want here is we want to have in each, like in the row that they're going to be in, 1, 2, 3, 4, 5, 6, there's 6 bikes in each row. We want to have the men on the ends, and then we want to have the women there, right? So that would be like in row 1. And then we would have 2 and row 3 where the people could be anywhere, right? So we've got 12 other people that we don't really care where they are, so they can just be arranged in 12 factorial ways. So that would be one scenario, and then we would have this 3 times over because they could be in row 1, row 2, or row 3, right? So if we look at how we can arrange our men and women, so there's 2 men, so we'd have 2 and 1, and then we have 4 women, 4, 3, 2, 1. Okay, so that is my number of favorable outcomes. So this comes out to be 2 times 4 times 3 times 2 times 1 times 1 is 48 times 12 factorial times 3. I'm not going to actually get that as a big number because it's going to be huge. And then the total ways that I can arrange them would be like if everybody just went wherever, and I'd have 18 bikes and everybody can be arranged wherever. So just 18 factorial would be the total number of ways that I could do it. So my probability of this event happening where my people end up in a row together is 48 times 12 factorial times 3 over 18 factorial. And if you put that into your calculator, it comes out to be not a nice fraction, or it comes out to be a decimal. So it's going to be 0.00001077. Okay, so it is a very minute possibility that these guys are going to end up in a row together with their friends when they go to their spin class. So that one is definitely the tougher of all of them. I think that the practice questions that I've given you are maybe not quite that complicated, but you may come across some where you will need to determine some cases. So you go ahead and practice them all. And when you get to the practice questions, I encourage you to express them all as a percentage, your answers, because it just makes it a lot easier to kind of see what's going on.